Hello. So in this video, I'm going to start chapter 23, electric current. What in chapter 22, when we introduce electric force and all that, that's about electrostatic. When charges are not in motion, they're in equilibrium, not moving. Now all these charges starting to move. So we're going to talk about electrodynamics, which is going to be the flow of a charge. And the flow of a charge is defined as current. Electric current means that flow of electric charge. So that's it, flow of electric charge. And this current, electric current, is a scalar. Although it has a magnitude value, and also you need to know the direction, but we treat it as a scalar. And by definition, the electric current is flow of a charge. So therefore, change in charge per time. So how much charge is flowing per time is the definition of electric charge. Let me see. So let's go into the note. Okay. Coming. So it's about the flow of a charge, chapter 23 here. Electric current. So it's the flow of a charge, right? So how can you have a flow of a charge? We are no longer electrostatic. Right, you need to have a force, right? So you need to have some kind of a force to have a flow, but how this electric charge field of force is, it's going to be dynamics, is that when these charges are in electric field, and it also has to have to be in electric field, and along with those electric field lines, that means that it needs to be having a change in electric potential, V, change in voltage. So remember, let's do the analogy with the mass. How does the mass moves? By the gravitational force, right? It moves down on the gravitational force is whenever you have height difference. You have a height difference, and the mass will move from higher location, higher height, higher y, to a lower. And there's a gravitational force that's pulling it down, so it moves downward. For the charge, electric charge, when you have so from the convention, we are going to use the electric charge as a positive charge. We know it has to be the electrons is actually responsible for all the motions. If you have electrons that's moved, then if you have a lack of electron, it becomes positive. The excess electron becomes negative. It is the electron which has a negative charge. However, by convention, we're going to imagine everything is with a positive charge. So everything is going to be the opposite motion of electrons. All right. So this plus Q charge will move. I should use the green. Will move from higher voltage to lower voltage. Remember I mentioned that you can imagine that electric voltage is like altitude when you think about it in a topological map, right? So the gradient, it's gonna go, if you put the mass on slope, the gradient, the change in altitude, when you have a change in electric potential, which is voltage, then it flows. So it's the same thing. You have a positive charge, it flows from high voltage to the lower voltage. So in this case, actually what's happening is that electron is moving, minus E, electron is moving from lower voltage to the high voltage. So when this electron is moving from low voltage to high voltage, it looks exactly like this positive charge is moving from high to low. So just think everything, because if it's a negative, it goes from low to high. It's just so much easier to think everything from high to low. So let's just do everything with this high to low. Okay. So positive charge. So this electric charge flow, so you see that the electric charge when there's potential difference. Potential, which in this case is a voltage difference. Okay, so whenever you have electric potential difference, so it has to be high to low, then you're always gonna have a electric charge that's flowing. And this flow of electric charge, the flow, electric charge. This is called electric current. All right, so the flow of electric charge is called the electric charge. And how do you actually quantify the electric charge is by, we use the notation I don't need that. How to delete this thing? Okay. So we use the notation I. Typically, we use I to represent the electric current equals to changing charge per interval of time. Okay, this means how much charge is flowing per time. Change in charge per interval of time. So it's coulomb per second, right? Let me just write it down lower. So that means that coulomb per second, and that's equals to 1 ampere. This big A is the unit for current, and it's ampere. All right. And you see this represents how much charge flow per second. How much charge flow per second. It's the rate of the flow, electric charge. All right, so this is how you can find out the quantity of electric current, the flow of a charge. So again, whenever it's actually just make sure how do we have the flow of a charge? It's the electrons. Electron is the source of a charge, right? And it is negative, but when electron moves to the right, that means that we assume that it's actually the right side is going to be the higher potential, and the positive charge is moving from right to left. All right. So the electrons move from low to high. So the high is going to be on the right-hand side. If the electron move from left to right, high is right. So we see the current is flowing from right to left, high to low voltage. And again, the trick is that you have a potential drop, the voltage drop, difference in voltage. Remember, the electric field lines and electric potential is perpendicular. And then you have electric field lines, that means you have a force applied on a charge, right? Same direction, electric field and a force is going to be the same direction if you have a positive charge. Then that means that it's the electric field lines are always perpendicular to the equipotential line. That means that when you have electric field lines or the force, then you have to have a change in voltage. That's why whenever you have a change in voltage, change in potential, then you're going to have a force. That's why electrons flow or the charge flow. And you can imagine that these electrons, flow of electron is like a water, right? The current, like a water current, it flows because if it's on a complete flat surface, if you don't have any pump, it won't flow. The water flows when you have a potential difference, right? Then you have a flow of a water. So as an electric current, you have a potential difference, right? The height difference like a thing. So voltage difference, that's why it flows. And I'm just going to tell you the batteries too. So the batteries, or like any voltage source that you have it in a wall outlet, or these batteries, right? These batteries. This is the acts like a pump, water pump or the electric pump. So when it says, let's see, oh, my kid's a little bit loud. Let's see, how many old person's eyes? If it's let me see, I forget if it's a 9-volt batteries or just a AA batteries. But if it's a, let's say, 9-volt battery, when it says 9 volts, that means that, so there's a plus and minus here. You see plus and minus? That means that there is the 9 volts pump. So if you treat that negative to be 0 voltage, then this is 9 volts. So the current that's coming from here, it's in a negative, lower voltage. This battery will pump up 9 volts up. Then it has the change in potential, change in voltage, so it can flow. All right, that's why it can flow. So what this battery is doing is not just giving the 9 volts, it's giving a pump, the change in voltage of a 9 volts or 120 volts. That's what it means by 120 volts or the 9 volts. It's giving a change in voltage. It's like a pumping up. So actually, technically, in the negative side, it can be 10 volts. But if the negative is 10 volts, then that means the positive will be 19 volts. This negative could be 20 volts, but that means that positive will be 29 volts. So the change in voltage is the 9 volts. That's what it means. You see, the change in potential is what it matters. Doing a work, dissipation of energy. Work is a change in energy. So I could just write that down. The batteries, electric generator, they all act like they're the voltage source, which means it's the pump. Provides change in voltage. This change in voltage. And another important thing about the electric current is that, so yes, you do need to have a change in voltage. So you have a plus and minus, right? And then you connect it to the light bulb. But you have to have a switch. And see in here, let's say it has a 3 volts battery. That means it means the change in voltage is the 3 volts. So let's say if this is 3 volts, what's the voltage here? That's going to be 3 volts. But then after you go through the light, it's going to be dropped to 0 volts. And then here's going to be the 0 volts. Because you use up that energy through the light. But this only happens when you have a switch that's closed. So for the current to flow, when there is change in voltage and when in a closed circuit. So if you have a circuit, this is called a circuit, okay? And then current flows from high voltage to the low voltage. But if you have an open circuit, then there's no current flows. Current only flows when you have a closed circuit. That's when you feel the electric field. Remember the electric field, it has to be continuous forever. So if you have any discontinuity, you're not going to have electric field. Therefore, there's no force and the current won't flow. Electrons are there, but you don't see the motion of electrons, consistent motion of electrons, and that's called a current. All right. Okay, so that's about it for the first video that I wanted to talk about, and I'm going to see you in the discussion.